If two events are independent, then one does not interfere with the other. For example, suppose you are tossing a coin and drawing a card from a pack. The result of the coin does not affect which card is selected. So these events are independent. If the events A and B are independent, then probability A and B equals probability A times B. You can multiply the probabilities of two independent events. You can solve simple problems on independent events by drawing up a table of equally likely outcomes. Let's do example 12. Janine has two spinners. One of them has the numbers 1, 2, 3. The other has the numbers 3, 4, 5, 6. Janine spins both spinners and adds the scores together. Draw up a table to show all the possible total scores. So let's organize a table. So for the answer of part A, I'm going to add the scores of the spinners. So in this way, I'm going to write the outcomes of the spinner which has 1, 2, 3, and in that way I will write the other outcomes from the spinner 2, which is 3, 4, 5, 6. So the scores is going to be their totals. So 3 and 1 will be 4, 3, 2 will be 5, 3 and 3 will be 6, and 5, 6, 7. This is 6, 7, 8. This is 7, 8, 9. So these are all of the outcomes from this experiment. In part B, work out the probability that Janine's total is 7. So there are 12 possible outcomes in the table, and 3 of them correspond to a total of 7. Therefore, probability of total of 7 is out of 12, there are 3, so 1 over 4. Example 13 is another question about independent events. Let's read. When Leston drives home from work, he has to pass through the 2 sets of traffic lights. The probability that the first set will be on red is 0.4. The probability that the second set will be on red is 0.3. And calculate the probability that both sets will be on red. So in part A, we are looking for probability of both red. So we are looking for probability of first traffic lights being red and second traffic lights being red. So these are independent events. They don't have any effect on each other. So I can use multiplication rule. So probability of red from first traffic light is going to be multiplied by the probability of the red from the second set of traffic lights. So this has 0.4, this has value 0.3. When you multiply, this is 0.12. Part B, it says calculate the probability that neither set will be on red. So we are looking for probability neither red. Neither of them must be red. So this is the case of probability from first set of traffic lights. I need not red. and from the second set of traffic lights I need not red. So I'm going to find the probabilities of being not red from the first set of traffic lights. This is 1 minus 0.4, and having not red from the second set of traffic lights is 1 minus 0.3. Then I'm going to multiply those probability values because these are independent events. I can multiply the values to calculate the probability of having both cases together. So 1 minus 0.4 is 0.6, 1 minus 0.3 is 0.7, and when I multiply it, I'll reach 0.42.